Now let's dive into deep in wind load discussion. Now let us consider our building is cladded building. Our building is cladded building which has wall on its periphery. Okay. Wall may contain windows and doors also. Now we will estimate our wind force by using IS 875 part 3. So now what we are doing is estimating the wind force. First we will estimate the wind force. Wind force is nothing but a wind speed calculation. Wind speed means design wind speed. I already discussed about this design wind speed where it's IS 875 part 3. Here design wind speed, this 6.3 clause. Here we have the formula Vz equal to Vb into K1, K2, K3, K4. Okay. Design wind speed. This is Vz equal to Vb into K1 into K2 into K3 into K4. Now Vz means design wind speed and Vb means here we have the explanation basic wind speed. What it says is so basic wind speed means figure 1 gives basic wind speed map of India, where our figure 1 is, this is figure 1 which has basic wind speed in meter per second based on 50 years return period. Okay, so what it's saying is figure 1 gives basic wind speed map of India. Basic wind speed we are taking from this map of India. Okay, as applicable to 10-meter height above the mean ground level for different zones of the country. Okay, now it is this figure 1 India map is applicable to 10-meter height from ground level. We are considering this wind speed. Okay, see here we have 33 to 55 meter per second. We have the color schemes. 33 means blue, this is 33. Okay, and yellow is 39 and this sky blue is 44. See here, this is 44, this region, and green is 47, this region is green, so it has 47 meter per second, and this red has 50 meter per second, this border area, and this one, and this 50 meter per second, and pink color has 55 meter. Pink color we have this much only. Okay, now let's read this. As applicable to 10 meter height above mean ground level means above 10 meter building, this basic wind speed is applicable. for different zones of the country. Basic wind speed is based on peak gust velocity averaged over a short time interval of about 3 seconds and corresponds to mean heights above ground level in an open terrain category. This wind speed they are taking is 3-second interval, mean interval, and category 2. Category 2 means this is category 2. Category 2 means here we have where it is category 2. Category 2 means open terrain with well scattered obstructions having heights generally between 1.5 meter to 1.5 meter and 10 meter. This is our category 2. Means basic wind speed considering what it considering above 10 meter height from ground level. This is first one. Second condition, category 2 it is considering, and it is based on interval of 3 seconds, which corresponds to mean height, means average height. Okay. Now basic wind speed presented in figure 1 have been worked out for a 50-year return period. What it means? 50-year return period means design period of 50 years. Design period of 50 years. Our figure 1 showing. Okay. Basic wind speed for some important cities towns is also given in Annex A. Okay, let's go to Annex A. This is the Annex A. Basic wind speed at 10 meter height for some important cities and towns. We can classify according to that figure 1 India map, or if you have city or town which is major, then you will get the wind speed here in Annex A, and some of introduced in newer amendment, which is IS 875 part 3 amendment 2. See here Annex A. Here we have some other cities also. You can see here if you have any missing cities in that older version of the IS 875, you can use this one. Okay, amendment. Now let's go back. Let's wind speed. Our basic wind speed for our building is VB. Our building is in Bangalore region. So let us see here in Annex A. It's present in Annex A, Bangalore. 33 meter per second is our basic wind speed. Okay, so VB is equals to 33 meter per second for Bangalore region. Okay, now K1 means K1 means probability factor risk coefficient, C 6.3.1. Here it is 6.3.1. Let's read this one. Figure 1 gives basic wind speed for terrain category 2 as applicable at 10 meter above ground level based on 50 years mean return period. The suggested life period to be assumed in design and the corresponding K1 factor for different class of structure for the purpose of design are given in table 1. In the design of buildings and structures, a reasonable basic wind speed having a mean return period of 50 years shall be used except as specified in the note of table 1. Okay, let's go to table 1. We will see table 1. In table 1, as per class of structure and mean probable design life of structure, according to this and basic wind, according to basic wind, we will get the K1 factor. Okay. Now for all general buildings and structures, our design life is 50 years, and for all it has stable only one value 1.0 1.0 1.0 for all. Okay, if you have temporary sheds structure such as those used during construction operations, for example form work and false work, structures during construction stages and boundary walls, if you have temporary sheds during construction operations, that's life is only 5 years. So for 5 years we are taking according to wind speed, we have to take these values. Okay, now this is for temporary structure, this is for general building structure. Now buildings and structures presenting a low degree of hazard to life and property in the event of failure, such as isolated towers in wooded areas, form buildings other than residential buildings. Means if you have other than residential buildings and which has hazard, means loss of life is less, the building which has loss of life is less, then we will design for that building is 25 years and the K1 value will be this. Okay, now it's other than residential building, we got the values. Now important buildings and structures such as hospitals, communication buildings, towers, power plant structures, power plant structures, means if you are designing 100 years or which it has the structure is important, then we are designing for 100 years. So for that we are using these values. Okay, now we have some one note also here. The factor K1 is based on statistical concepts which take into account the degree of reliability required and period of time in years during which these will be exposed to wind, that is life of structure. Whatever wind speed is adopted for design purpose, there is always a probability, however small, that it may exceed in storm of exceptional violence more the period of years over which there is a exposure to the wind, more is the probability. What it's saying is we are designing according to period and period means this design period. If we have more design period, then the more it exposed, it will expose more because we have more design period. So you can check here, if we have designed for 100 years, see here we are designing here 100 years, then for 33 1.05, for 39 wind speed 1.06, it's increasing order, right? But here see here we are designing for less life, then it's 0.949291, it's decreasing order. Okay, see here also, here we are designing for only 5 years, means exposure is less and hazard it may come or it may not. So here also it is 0.82, 0.7673, it's decreasing order, right? See here is our normal 50, normal for normal structures it's 50 years, then it's constant. So this point explaining that one only. If our structure's design period is more, then it will increases. If our structure design period is less, then it will decreases. Okay. Larger the return period ranging from 100 to 1000 years, implying lower risk level, in association with larger period of exposure, may have to be selected for exceptionally important structure. What it's saying is, if your building is only general normal building residential, but you are designing for 100 years, then you have to consider these values. Okay, so that point is saying this much. Now, according to our building, ours is normal building and design period is 50 years. So, and 33 is our wind speed. So, we will take K1 as 1.0. So, our K1 value is 1.0. Now, K2 value. K2 means, see here, terrain roughness and height factor. See 6.3.2. Here is 6.3.2 terrain height factor, K2 factor. Okay. Now, in this we have 4 categories. Category 1 is which is exposed to open terrain with few or no obstructions and in which the average height of any object surrounding the structure is less than 1.5 meter. Means in category 1 we have obstructions less than 1.5. In category 2 we have obstructions 1.5 to 10 meter. In category 3 we have obstructions more than 10 meter height. Okay, and our last final category 4 is terrain with numerous large highly closed spaced obstructions. The equivalent here obstructions are above 25 meter. This is very dense city. Okay, this is our category 4, but ours is in Bangalore region and we fall in category 3 because terrain with numerous closely spaced obstructions having the size of building structures up to 10 meter height with or without a few isolated stall structures. The equivalent, this category represents well wooded areas and serves towns and industrial areas full or partially developed. Ours is partially developed, so we are taking the category 3. Okay, according to category 3, now we have to check the table 2. Here it is table 2. According to terrain category, our building height falls under, our building height is around, let's see, this is our building height. You can take this one or you can take this one. I will take this 22. See here Z you will see here Z is 22 meters. So what we have to do is we will take the K2 value as 22, means it falls under 20 and terrain category 3. If you want exact, then the note is saying that for intermediate values of height Z in a given terrain category, use linear interpolation. You can use interpolation also for exact accurate value. Now I am taking 20 meter 1.01. Okay, K2 value is 1.01. Now K3 means, where it is, see here, K3. K3 is topography factor, C 6.3.3. 6.3.3. This is our topography K3 factor. Here the basic wind speed VB given in figure 1, VB we already seen, takes into account the general level of sight above sea level. This does not allow for local topographic features such as hills, valleys, cliffs, escarpments or ridges, which can significantly affect wind speed in their vicinity. The effect of topography is to accelerate wind near the summits of hills or crests of cliffs, escarpments or ridges, and deceleration the wind in valleys or near the foot of the cliffs, steep escarpments or ridges. What it says is, it's saying if ours is in, if our building is in hills, valleys, cliffs, escarpments like this, means if we have hills, in simple words I will say, if we have hills like this, means then what happens, the wind will touch this, and here this is our top level of the hill. What we tell, this area is, we call this area, and this area at the top of the hill we call it as crests. At crest level it accelerates the wind speed. Here wind speed will be accelerated, and if this is called crest, if crest is present then it accelerate the wind. If escarpments or ridges are present, means ridges means, I will show you. See, this is our ridges, this is our ridges. If ridges are present, then what happens, the wind will touch and decelerate the wind velocity. Okay, I will show you crest also. See here, this is crest, this is crest at the tip of the hill, we call it as crest. Okay, summits of hill or crest accelerates, wind is accelerated, and escarpments or ridges, wind is decelerated. Okay, now read this one. The effect of topography shall be significant at a site when the upwind slope, wind slope, this is our normal wind, upwind slope means, now this is the, how I can tell you is, if we have hill, then this is the upwind slope, means this is theta. Okay, this is called upwind slope. Upwind slope is more than about 3 degree, and below that the value of K3 may be taken to be equal to 1. What it says is, if our theta is less than 3 degree, then we will take it as 1.0. The value K3 is confined in the range of 1 to 1.36 for slope more than 3 degree. If our theta value is, this theta value is more than 3 degree, then it varies from 1 to 1.6. A method of evaluating the values of K3 for the values more than 1.0 is given in Annex C. It may be noted that the value of K3 varies with height above ground level at maximum near the ground and reducing to the 1 at higher levels. Okay, now we will see the Annex C. This is the Annex C, effect of cliff or escarpments on the equivalent height above ground K3 factor. Okay, here our main formula is K3 is equals to 1 plus C into S naught. C means this is the value of C. If our theta S is, our theta is greater than 3 degree and less than or equal to 17 degree, then we will use this 1.2 Z by L. Z means, I will show you. This is our upwind. This is our upwind, right? This is theta S, and this is from bottom to this tip of the hill. The height is, we call it as Z, and this is average ground level. From top to average ground level, that is H. Okay, and this distance is our L distance. Okay, this is crest value, crest. Here it is 1.5 LE, 2.5 LE. Okay, now Z means, this Z means this is the from bottom to tip of the hill height, that is Z, and L means this L, this value, this is L. Okay, if our theta S is more than 17 degree, then we will take C directly 0.36. Okay, now S naught, this S naught, this S naught is the factor S0, S naught or S0 should be determined from figure 14 and figure 15. Now where is the figure 14 and 15? This is the figure 14 and this is the figure 15. This is for ridges and hill. This chart is for hill. This chart is for cliffs and escarpments. Here this is the X by LE and this is the H by LE, where X and LE, see here, this is the X value and LE means this LE. By using this C1, we will use the LE. If theta S is greater than 3 degree and less than 17 degree equal to 17 degree, then L is equal to LE. L is equals to LE. If more than 17 degree, then Z by 0.3. Z is this Z divided by 0.3 is our LE value. Okay, and here h by LE, here x by LE, and here h by LE. You have to take the S0 value if it is crest. If it is cliff and escarpment, you have to use this one. Here is h by LE and z by LE, and this is the x by LE. Okay, now our final conditions are: if theta s is less than 3 degree, then k3 equal to 1. If theta s is greater than 3 degree or less than 17 or equal to 17 degree, then k3 equal to 1 plus c s naught, where c is this one, 1.2 z by l. If greater than 17 degree, then c is directly 0.36. Now our building is in city, so it's less than 3 degree, so I will use k3 as 1.0. Now k4. K4 means here importance factor for the cyclonic region, C 6.3.4, 6.3.4. Okay, here it is 6.3 importance factor for cyclonic region K4. The east coast of India is relatively more vulnerable for occurrences of severe cyclones. On the west coast, Gujarat is vulnerable for severe cyclones. Studies of wind speed and damage to the buildings and structures point to the fact that the speeds given in the basic wind speed map are often exceeded during the cyclones. During cyclones in coastal areas, the speed will exceeds, so we have to take this K4. Okay, the effect of cyclonic storms is largely felt in a belt of approximately 60 km width at the coast. Means our coast, this is our coast, then up to 60 km belt, 60 km belt, it will affect the cyclonic storms. Okay, in order to ensure better safety of structure in this region, 60 km wide on the east coast as well as on the Gujarat coast, the following values of K4 as recommended in IS 15498 are stipulated as applicable according to the importance of the structure. You can see this 15498 IS code, and here we have our K4 values for cyclonic regions. Normal structures of post-cyclonic importance for the emergency services such as cyclonic shelter, hospitals, communication towers, etc. means important structures, we will take it as K4 value as 1.3 in coastal regions which has 60 km belt. Okay, and if your structure is industrial, then you have to take the 1.15, and all other structures is 1. Right, east coast means, see here, this is east, north, west, south. This east course is applicable to K4, and this Gujarat side west coast also applicable to that K4 value. And another thing, we will jump into 6.6. see here, cyclonic storms form far away from the sea coast and gradually reduce in speed as they approaches the sea coast. Cyclonic storms generally extend up to about 60 km inland after striking the coast. Their effect on the land is already reflected in the basic wind speed specified in figure 1. The influence of wind speed of the coast up to a distance of about 200 km may be taken as 1.15 times the value on the nearest coast in the absence of the any definite wind data. The factor 1.15 shall be used in addition to K4. If we are taking this K4 value, then addition to this we have to take 1.15 factor if that structure is falls under 200 kilometer range. If our definite wind data is not available at that case. Okay. So our building is normal building, means our building comes under all other structures and we are not in coastal areas. So the value we will use this 1.0. Now our K4 value is 1.0. Now Vz equal to Vb means 33, K1 is 1, K2 is 1.01, K3 is 1, K4 is 1, and our Vz is 33.33 meter per second. Now this is our wind speed. Now we calculated the wind speed. Now we have to calculate the wind pressure. Wind pressure means I already discussed about this Pz. This Pz is only wind pressure at height Z. Okay, so this formula is present in 7.2. Here it is, design wind pressure. Pz is wind pressure at height Z. 0.6 Vz square is our formula. Okay, 0.6 Vz square is our formula. 0.6 Vz means this 33.33 square. Now what is the answer? 666.533 Newton per meter square, or what we just 667 we can call it as Newton per meter square. Pz value. Okay, now rest we will see in next session.